Good morning. Today we will work on the composition of two topological conjugations. Let's say we have three matrices A, V, and C, and you know that the topological conjugation can be it's an equivalence relation. So it is transitive, meaning that A is topologically conjugate with B implies that it is also topologically conjugate with whatever is conjugate with B, in this case C. But this doesn't prove that topological conjugation, I mean the homomorphism that is doing this relation, let's say H and G, the homomorphism that guarantees this conjugation, holds that G composed with H will be the homomorphism that conjugate A and C. So we will review this today. For that, let's start remembering the definition of topological conjugation. Let's write it here. We say that H, it's an homomorphism. In this case, let's suppose that A, V, and C are matrices with real entries with dimension n. So this will be an homomorphism from Rn into Rn, such that H applied on the flux of A is equal to so this is for the first, and for the other homomorphism, let's say that G is also an homomorphism, and in this case this will be equal to so what happens when we composed in this equation, when we compose it with G? So it will be G composed with H on the first flux will be equal to G on V. Let me put it here. Like this, right? But then, since this also holds because G is a topological conjugation, then we can replace this thing by the flux of C in T of G in X. But here X is H of X, so this will be G composed with H in X. So you can call this some function J, and this will also be J. So it holds the property that we are looking for. But then you also remember that the composition of homomorphisms is an homomorphism. I mean, because an homomorphism to be one, it needs to be continuous. It needs to be a bijection, and its inverse should also be continuous. So if we have two homomorphisms, I mean two functions that are continuous, then the composition is continuous. And if they are bijections, then its composition will also be a bijection. And if its inverse is continuous, then the same applies, the same holds. So this proves that the composition of topological conjugations is also another topological conjugation.